Good day, everyone. So today we will be having another module to discuss. We have module 21 or current and resistance. So ang learning objective natin dito is makakalculate na resistance when the resistivity of a wire is known. So may problems tayo later na given ang resistivity and then kakalculate natin yung resistance or yung R. And then also kailangan natin i-compute yung resistivity ng isang conductor na gawa sa iba't ibang material. So conductor is a classification of material which we discussed from previous modules. Classification of material wherein kasama niya si insulator and si semiconductor. Okay? So dito, yung current and resistance is mostly under ng electrical engineering na course. But as a civil engineer or civil engineering, kailangan pa rin natin maging aware dito. Okay, so since nag-build tayo ng buildings and projects, and meron dun sa may project na yun ng mga electrical circuit, at least alam natin kung ano yung mga pwede natin iwasan sa pag-design and pag-construct ng mga ganong projects. Anyway, let's proceed to our discussion. We have here current or electric current, and then ang symbol niya is I. When we say current, electric current or simply current, it is the time rate of flow of charge. Charge yung Q, kung nakikita nyo dito, ito yung ating Q. Diba? Ito yung Q. And ang tawag natin dyan is charge. And then we have T or time. Then yung I yung is current. So dito sa next part natin, current is equal to charge over time. Pag sinabi natin rate of flow or flow rate of, laging may involved na time. Okay? So as you can see here, parang kinross multiply like current sa time and then yung charge. Yung 1C, ito yung charge natin. Okay? And yung unit ng charge is equal to 1 amperes, which is a unit of current. Ampere ang unit ng electric current or current. And then of course, yung time is second. So pinakita lang natin dito, ano yung unit ng ating mga values dito. And then we also have here the resistance and resistivity. When we say resistance, it is defined to be the ratio of the potential difference or yung voltage natin na V across a conductor to the current I through the material. Pag sinabi natin ratio, division lang, ano? Kung ano yung unang binanggit na value or unit, yun yung ating nasa ibabaw or yung numerator. So as you can see, ang unang binanggit is yung ating potential difference. Kaya nasa taas yung V. Across a conductor to the current I. Ayan. So nasa ilalim yung I. Kasi dahil pangalawa siya binanggit. So this equation R is equal to V over I is pasok sa Ohm's law. Okay, so etong mga values na to, given yung dalawa dyan, then isa yung nawawala. Okay. So sa unit naman natin, ang R natin is equal to 1 ohms. Ang unit ng R or resistance is ohm. Okay. Tapos ang unit ng V, kagaya ng na-discuss natin from previous module, is volts or voltage. Yung amperes naman is para sa I, gaya ng sabi natin kanina sa previous part of this discussion. Okay, we have here another concept na connected sa resistance is the resistivity. So property lang naman ng material sa resistivity, ano, connected siya sa flow of electric current sa isang wire. So dito, binanggit in resistivity, kapag daw meron kang long wire, halimbawa meron kang dalawang wire wherein magkaiba sila ng area. So halimbawa meron tayong wire dito, ayan, tapos halimbawa wire yan, tapos meron kang isang wire pag ganyan. Same length lang naman. Okay. So meron kang area dito, tapos may area ka. Tapos yung length natin is parehas lang. Ayan. So meron tayong length na L. Parehas lang sila. Pero yung resistance dito sa una is mas malaki kaysa sa resistance ng pangalawa. Actually, yung concept na to is eto lang naman. Pinasimple lang natin. Okay. Yung concept natin, yung long wire has a higher resistance than a short wire. Aside from that, we have the current density. Pag sinabi natin current density, it is, ang symbol nito is J. In the conductor is defined as the current per unit area. So, ito yung J, yung current density natin. I is for current, and then A is for area ng ating wire. So, ang unit niya, of course, yung I kasi, ang unit is ampere or A. And then area is unit squared. That's why nagkaroon ka ng A over M squared. So, depende sa given naman yan. Pero yung I natin is laging A. For resistance and temperature, meron tayong table dito wherein yung material is nakalista dito. We have silver, copper, gold, and others. Meron silang tigitiisa na value ng resistivity, which is ohm meter, and then temperature coefficients, o parang alpha yan. Ang unit niya is per uh, degree Celsius. So we have here formula ng ating resistance, ay ng ating resistivity. Yung resistivity natin is parang rho. So parang density siya dun sa ating static fluid na topic. But here, yung rho na ito is resistance. Resistivity, sorry. Resistivity. And then we have resistivity sub O, 1 plus yung temperature coefficient na alpha, yung final temperature minus initial temperature. Yung P sub O, yung rho sub O is the initial uh, resistivity. And if we will be simplifying our values, we will have a temperature coefficient alpha is equal to change in resistivity over original resistivity over change in temperature. So tatandaan lang naman natin to, and this table will be provided to our during our quizzes and exams. Okay, so let's proceed to our example para mas maintindihan natin yung kahit pa paano yung concepts na pinresent natin kanina. Okay, so we have here for our first example, the difference of potential V sub 1 or electric potential V sub 1 between the terminals of an electric heater is 120 volts when there is a current I sub 1 of 8 amperes in heater. What current will be maintained in the heater if the difference of potential is increased to 180 volts? So first, isulat muna natin ano ba yung mga given natin. So yung given, meron tayong V sub 1 na electric potential. Ito ay 120 V. And then binigyan din tayo ng current or I sub 1 na 8 amperes. So meron din binanggit na nag-increase yung ating potential or V sub 2 is equal to 180 volts. So okay. So ang hinahanap sa atin is current daw. So I ang pinapahanap sa atin. Okay, so gamitin natin yung ating Ohm's law. So meron tayong formula sa Ohm's law na isa sa mga nabanggit natin kanina is V is equal to IR, or yung ating potential is equal to the current multiplied to resistance natin. Ano? So ang pinapahanap sa atin is I. Binigyan tayo ng isang initial voltage or initial potential tapos initial current. So try natin i-substitute dito, hanapin natin yung initial resistance natin. So R is equal to V over I. So divide both sides by ano lang to, divide both sides by I. Yan, para makuha natin yung R is equal to V over I. So R is equal to yung voltage natin na 120 volts and then I natin na 8 amperes. So pag dinivide natin yan, yan ay 15 ohms. Okay. So binigyan tayo dito ng V sub 2 o yung pangalawang potential natin. Pinapahanap yung I. Yung R natin, i-retain lang natin yan. So since same system lang naman tayo, yung electric heater, so pwede natin gamitin yung R. Okay. So syempre pag nagbago yung ating potential, magbabago din syempre yung I natin. So we have here I is equal to V over R. Okay, so meron tayong V na bago, yung 180 volts, tapos yung nakuha natin na R na 15 ohms. So yung current natin is magiging equal sa 12 amperes. So ganun lang. Direct substitution lang tayo dito. So next example, we have here, calculate the resistance of a copper wire, 250 meter long and 1.5 millimeters in radius. Tapos binigyan tayo ng temperature na 20 degrees. Okay. So, ang pinapakompute is resistance o yung ating R. As you can see, meron tayong table wherein nakalagay ang resistivity and the temperature coefficient alpha ng kada material. So, ang gagawin natin, balikan natin yung formulas natin kanina. Meron tayo na introduce na formula na R is equal to rho L over A. Okay. So yung R natin is yung resistance na pinapahanap. Yung rho is the resistivity. And then L is the length of the wire. And A is the area or cross-sectional area of the given wire. So focus tayo sa tanong na banggit na ang wire natin ay isang copper. If that's the material ng ating wire, check natin yung row ng copper dito, which itong pangalawa. No? So check natin ano ba ang kanyang resistivity. So resistivity niya is 1.7 times 10 raised to negative 8. Ang unit natin is ohm meter. Sige, plug in natin sa ating formula. We have 1.7 times 10 raised to negative 8 times, ano yung length sa atin? Binigyan tayo ng 250. Yan. Over, ang area natin is pi. Then yung radius natin na po 1.5 millimeters. Pero hindi natin siya i-substitute as 1.5. Ko-convert natin siya as meter. Kasi meter ang 250. And ohm meter ang ating resistivity. So, 1.5. Since millimeter yan, times 10 raised to negative 3. Don't forget na naka-square yan kasi pi r square. Anyway, yung ating R, pag pinag-in natin sa calculator yan, yan ay 0.6 ohms. Ganun lang siya computin. Mabilis lang. Basta alam niyo yung formula ay nabasa niyo na kung ano yung material sa tanong and you have the table na resistivity and temperature coefficients, okay, masasagot niyo yung questions dito. So we have here example number 3, an aluminum wire of diameter D and length L has a resistance of 1.5 ohms. So sulat muna natin yung given isa-isa. So we have for the diameter, sabi natin D sub A is D. And then length ng unang wire natin or wire A is L. For its resistance, ito ay equal sa 1.5 ohms. Okay, so sabi, ano daw yung length ng another aluminum wire? Sabihin natin, wire B, ito yung pinapahanap sa atin. Okay, so binigyan tayo ng diameter. Diameter B is equal to 2D. So binigyan din tayo ng resistance niya, which is equal to 6 ohms. Ayan. So since same lang naman ang temperature niyan, therefore, ito kasi yung aluminum eh. So itong value ng resistivity o yung ating rho is parehas lang dito sa wire A and wire B. So we could just say na aluminum wire A is equal to resistivity of aluminum wire B. Balik tayo sa formula ng resistance. So R is equal to resistivity times length over area. So, diderive natin, papalabas natin si resistivity na rho. Magkakaroon ka ng RA or AR, okay lang naman, over L. Okay, so substitute natin dito yung ating mga values. So, rho, aluminum wire A is equal to, resistance niya na 1.5, tapos yung area natin is pi over 4. Then, D squared over L na L lang ganyan. So, simplify lang natin yung values natin. Yung 1.5 divided by 4 is equal to 3 over 8. 3 pi d squared over 8L. For aluminum wire B, meron kang 6 na resistance and then area na pi over 4 2d squared. Dito yung squared. Over yung length na pinapahanap sa atin, L sub B. Simplify lang natin, we have 6 over 4 times 2 squared. Yan ay 6 pi. 6 pi, naging squared yung D over L sub B. Gamitin natin to, pag equate natin to, ito yung equation 1, sabihin natin. Tapos ito yung equation 2. Therefore, 3 pi D squared is equal to over 8L, 6 pi D squared over LB. Since ito ay parehas lang, pi D squared, tapos may 6 ka dyan, may 3, ito 2 na lang matitira. Yan. Meron ka ditong 1 na lang. 1 na lang itong kabuuan. Yung 3 pi D squared kanina, magiging 1 na lang yung dahil na-cancel out. So meron kang 1 over 8L is equal to 2L sub B. Cross multiply, you will have L sub B is equal to 2 times 8L is 16. And therefore, yung length ng ating another wire is 16 times L. Kumbaga, 16 times noong length ng unang wire. Okay, so for our last module in Physics 032, we have module 22 for the direct current circuit. So here in direct current circuit, ang ating objective is of course makompute yung EMF. Ano ba yung EMF? It is the electromotive force, with internal and external resistance. Also, we have to calculate the resistance of series and parallel combinations of resistors. So sa previous modules natin, ang na-compute natin is yung sa may capacitors in series and parallel. Pagdating naman dito is resistance or resistors naman yung i-analyze natin. So we will present both series and parallel, yung mga relationship ng values natin. Ipapresent natin later while computing values sa ating sample problems. So here we have the concept, quick presentation of formulas and relationships between the values. So measurement of electromotive force or EMF, potential difference, and current. So ito yung relationship nila. Meron tayong formula dito sa left side of the screen. Ayan. So we have here I or current is equal to para siyang epsilon, di ba? Pero yan ay yung EMF na tinutukoy natin. Over, yung R na malaki is the resistance. Okay? Yan yung ohm. And plus, yung may maliit na R, yung plus is the internal resistance. So, etong formula na nasa baba is just the derivation ng formula natin sa taas. Moving forward sa ating resistors in series and parallel. For series, as you can see, yung V natin is equal to IR, which is galing sa Ohm's law. Okay? So V is equal to IR. Yung V is total, I and R is the total values in this whole series connection. For V sub 1, ganun pa rin yung formula. But as you can see, pare-parehas lang yung I niya. Meaning, I is equal to I sub 1 to I sub 2 and to I sub 3. Equal lang lahat ng I natin. Equal yung I na dumadaloy sa lahat ng resistor. Okay. For the volts or voltage ng ating connection, para makuha natin yung total volts, we simply add the voltage sa kada resistors natin. Okay? And lastly, for the resistor, para makuha natin yung resistance ng ating buong series connection, you just simply add those resistance na binigay kada resistor. Okay, kaya R is equal to R1 plus R2 plus R3. Okay, so ito ay mahalaga, pakitandaan na lang para makapag-compute tayo ng values. Next, we have the resistors in parallel. Pag sinabi natin parallel connection, as you can see, parallel siya, para siyang resistors, para siyang capacitors in parallel. Ganun yung itsura din niya. Yung connection niya, as you can see, nakaparallel. Yung resistors natin dito is parallel lang. Ito yung isa, then parallel yung R2 saka yung R3. So ganun yun i-illustrate. For the relationships naman ng ating value, kung dun sa ating resistor in series, ang equal is I, pagdating naman sa parallel sa resistors, yung voltage naman ang equal. Okay? So I is equal to V over R is just formula na galing din sa Ohm's law, no? So galing lang tong I is equal to V over R dito sa nasa taas na V is equal to IR. Derivation lang. So since yung V is equal lang naman sa lahat, yung V na nakuha o yung V na given is just pwede mong gamitin doon sa ibang values. For the I values, makukuha natin yung I total pag kinuha natin yung sum ng current sa kada resistor natin. So I is equal to I sub 1 plus sub 2 plus sub 3. Okay. And lastly, for the resistor or resistance ng ating parallel connection, we will get the sum of the reciprocal of our resistance. Okay, so as you can see, 1 over R, yung R is yung total resistance sa ating connection, is equal to 1 over R sub 1 plus 1 over R sub 2 and 1 plus, and plus 1 over R sub 3. Tapos, pag nakuha natin yung sum nito, babalik na rin natin, kunin natin yung reciprocal para ma-solve yung R. So, let's proceed to our example para mas ma-appreciate natin yung ating values. Mas ma-appreciate natin yung formulas na binigay. Okay, we have here example number 1. For direct current circuit, calculate the terminal potential difference of the circuit shown in the figure. Then, ano ba yung potential difference dito sa ating linya, dito sa ating connection? So, meron tayong formula kanina na in-introduce. I is equal to parang epsilon, parang E, which is our EMF. So, R is plus R na maliit. So, yung I natin is a current. Current yan. Yung E natin is EMF o yung ating 6 volts. As you can see sa ating illustration. So 6 volts. Yung ating resistance is binigay din which is 2.80 ohms. Plus yung IR ay yung R na maliit is yung internal resistance sa 0.2 ohms. Ayan. So direct substitution lang, simplify lang natin, ang magiging value na is 2.8 amperes. Pero ang pinapahanap talaga dito sa problem is the terminal potential difference or yung V. So na-box ko lang. Na-box ko lang yung 2A. So meron din tayo kaninang formula na V is equal to epsilon minus I. Meron din tayong formula na V is equal to EMF minus the product of current and internal resistance. Okay, so meron tayong E na 6 minus yung 2A na nakuha natin kanina. And then internal resistance na 0.2. V is equal to 5.6 volts. So ito na talaga ang ating final answer, which is the terminal potential difference of this circuit connection. Okay, so we have here another example. The values of three resistances are 10, 4, and 6 ohms. So meron kang tatlong resistors as you can see dito sa ating illustration. Calculate the total resistance if the resistors are connected in parallel. So as you can see dito sa portion na to is parallel yung ating tatlong resistors. Ayan. So yung current natin is the daloy mula dito sa ating source na V papunta dito sa part na to, no? Tapos maghihiwalay sila sa point na ito. Ayan. Yung isa pupunta dito. Yung isa sa R sub 1 and then sa R sub 3. So balik lang tayo sa ating relationship ng resistors, ano? So, ang ating resistor na ina-analyze is nasa parallel. Therefore, yung mga conditions and relationship between the values is i-analyze natin based doon sa na-discuss natin na resistors in parallel. Sulat muna natin yung given. We have R sub 1 is equal to, nakasulat naman na sa drawing to. Para hindi redundant, ulit natin isulatan. So, sige, relationship. So, in parallel, ang ating volts dyan is equal lang. So, V sub 1, V sub 2 is equal to V sub 3. So, yung volts na to, pag dumaloy dito sa ating point, lahat yan equal lang volts yan. Okay. So, pero yung ating I sub 1, I sub 2, and I sub 3 is hindi magkakamuka, lalo na yung I. Yung I is total of these three current. So, ilagay lang din natin, I is equal to I sub 1 plus I sub 2 plus I sub 3. Ayan. So, ang pinapahanap sa atin dito is total resistance. So, total resistance o yung R natin. Wherein ang formula natin doon is 1 over R is equal to 1 over R sub 1, 1 over R sub 2, plus 1 over R sub 3. Ayan. So, syempre, wala tayong R sub 1. Meron ba? Meron. Ayan. Meron naman na din tayong R sub 2 and R sub 3. So, hindi na natin to gagamitin. Okay? So, parang na-present lang din natin. Okay. Anyway, gamitin na lang natin to para mas mabilis. Okay, 1 over R is equal to 1 over 10 ohms plus 1 over R sub 2 na 4 and 1 over 6. Ayan. So, pag tinotal natin yan, pwede naman natin i-calculate yan. Ang magiging value natin dyan is 1 over is 31 over 60. Pero hindi naman yan yung kailangan natin. Kailangan natin pang i-reciprocal yan. So, pabaligtarin lang natin yung R, dadalhin natin sa taas. Yung 60, dadalhin sa taas. Yung 31, ibababa natin. Therefore, R is equal to 60 over 31 ohms. Or kung nakadesimal ang kailangan natin, ito ay equal sa 1.935 ohms. So, ito ang ating final answer for example number 2. So we have here example number 3, 4 resistors in series parallel combination as shown in the figure. The total resistance of the combination. So calculate natin yung total resistance natin. So R is equal to, so since nasa series tayo, pero meron tayong nakaparallel. So yung 6 and 3 nakaparallel yan. So bago tayo pumunta sa series connection ng pag-a-analyze, dun muna tayo sa parallel na dalawa. So kanina nabanggit natin na yung resistance sa parallel is 1 over R is equal to 1 over R sub 1 plus 1 over R sub 2. So etong portion na to, kunin natin yung total resistance sa part na yan. So we have 1 over R is equal to 1 over R sub 1 na lang is yung 6 plus 1 over R sub 2 yung 3. So yung R natin, shortcut ko na. Yan ay 1 half or 0.5. Pero kailangan pala natin baligtarin. Yan, 2. 2 pala siya. 2 ohms. So sa calcul nyo na lang i-input. Basta ang mahalaga yung R natin, hindi nandito sa baba. Anyway, meron ka ng R for this portion only ha. Sige, lalagyan natin ng note. Ngayon, pwede natin i-redraw. Drawing lang natin ulit. So, ito yung R natin na 2 ohms. Tapos, we have 4 ohms. And then, yung last natin is 8 ohms. 0.6. Ayan. So, ngayon, naka-series na tayo. So, pagdating sa series, ang total resistance natin is RT is equal to R sub 1 plus R sub 2 plus R sub 3. Ay kung ganun pala, substitute lang natin yung value. Yung R1 natin, itong R na lang. Plus R sub 2 is yung 4 plus R sub 3 na 8. Therefore, the total resistance of our series parallel connection is equal to 14 ohms. So, yun lang. Ganun lang siya isolve. So, hindi ka po pwedeng dumire. Halimbawa, hindi ka pwedeng dumiretso ng series. Hindi mo pwedeng i-analyze to. Tapos nakahiwalay na i-analyze to. Baka mamali ka. So, ang proper way of analyzing this kind of connection is kunin mo muna simplify mo muna yung mga connection mo into series. Kunin mo muna yung mga nakaparallel. Gaya ng ginawa natin. Okay, so thank you so much for listening and watching our lecture video. Today, our last module here in P6032. I hope you at least nagkaroon kayo ng konting understanding galing sa akin dito sa P6 buong semester. So, good luck to your exams, particularly sa inyong Common Final Exam or CFE. So if you have questions, clarification with regards to our discussion and topics, you may raise them in our group chat para ma-clarify natin as much as possible. So thank you and goodbye.